So this is the next unit, that is unit 5, queues. So in this chapter, first part is the introduction part, then the objectives, then the EDT, abstract data type queue, then implementation of queue, array implementation of queue, same thing, linked list implementation of queue. We can implement this queue by using array, and also we can implement this queue by using linked list. Then multiple queues, implementation of multiple queues. Multiple queues means more than one queue. Then implementation of circular queue, it's another type of queue that we are studying in this chapter, that is circular queue. Then array implementation of a circular queue. Then we will discuss what is circular queue and how we can implement this circular queue by using array and also by using linked list. Then implementation of DQ, another type of queue, that is DQ means double-ended queue. We will discuss DE, double-ended queue. Then the implementation of this DQ also by using array and by linked list. So these are the parts that we are discussing in this chapter, unit 5, queues. So first part, introduction. So queue is a linear data structure used in various applications of computer science. So this queue, what is this queue? Queue is a linear data structure. All of you are familiar with this. What is linear data structure? So it's used in various applications of the computer science. So like people stand in a queue to get the particular service. So all of you are familiar with these queues. So in our disciplinary manner, if we want to get some services, we should stand in a queue. So like people stand in a queue to get a particular service. So various processes will wait in a queue for their turn to avail a service. So why we are waiting this queue? We are waiting for our turn to get our service. So that is the disciplinary part. So various processes in computer science, various processes will wait in a queue for what? For their turn to avail a service. So in computer science, it is also called first in, first out. So this queue that we are using is in the FIFO manner. That means in a queue, we are entering in one end and we are standing the front end. The entering end, that we call it as the rear end, and we are standing in the front end for getting our service. So the fashion that we are using in queue is first in, first out. Who is coming first will get the service and will go out first. So first in, first out. FIFO. And start last in, first out. In start, we use the last in, first out fashion. Okay. So in this chapter, we will study about various types of queues that we will discuss in the introductory, the first part, the different types of queues. So in queue that we are using FIFO manner or FIFO fashion, first in, first out fashion. Then abstract data type queue. What do you mean by abstract data type? So an important aspect of abstract data type is that abstract means they describe the properties of a data structure without specifying the details of its implementation. So when we are describing something, the core part, we are describing only the core part. Describe the properties of data structure without specifying the details. We are explaining or discussing something of the core part and not describing the details of the thing, that we call as abstract. The essential part, that we called it as abstract. So we are discussing only the essential part. So we are that type that we call it as abstract. We are explaining the main part or the core part, that is abstract, and we are not specifying details part. So the important aspect of abstract data type is that this abstract data type describes the properties of a data structure without specifying the details. So the properties can be implemented independent of any implementation in any programming language. So we are describing this abstract data type like queue or stack and all, and we are describing or we are discussing only the abstract data type. That means we are discussing or describing queues or stacks or trees. We are describing this, and we can implement it by using array or linked list, or we can implement this, or we can write program by using any programming language. We are not describing all these things. We are describing or we are discussing only the abstract part. What is queue? Then what is the fashion that we are using in queue? What are the different types of queues? And we are describing or only that part. And based on that, we can implement it by using array. We can implement by using this. Then linked list. We can implement this queue or a stack or tree by using linked list. Or we can write program by using any of the programming language. We can implement it by using C or Java or C++. So we are not describing that things. We are describing the abstract part. Okay. Then queue is a collection of elements, or queue is a collection of items for which the following operations are defined. In stack also we describe the operations. Here in queue, create queue is there. What is that create queue? Creates an empty queue. So we can create a queue named the letter Q. Then is empty. Then we can check that queue is empty or not. So is empty of queue is a Boolean type predicate that returns true if the the queue is empty, and return false otherwise. So Boolean means what? Is empty means asking that is the queue is empty. Then the result will be either true or false. So that type of data type, that we call it as Boolean data type. From this Boolean data type, we will get any of these values. It may be a true value or a false value. So we call it as a Boolean data type. So is empty, we are asking that, or we are finding that if the queue is empty or not. The result will be either true or false. That type of data type, that we call it as Boolean data type. Then add queue. Add queue of queue comma item means we are entering an item. We are adding an item to the queue. So we are adding an item. Then Q means, the letter Q means that is the name of the queue. Then what comma item means, that is the item that we are adding to the queue. So add queue of when we are adding an item into the queue, we should have the queue name and that item that we are going to add. That is queue comma item. What is that? Adds the given item to the queue. Q. The letter Q means that is the name of the queue, and the item is the item that we add it to the queue. And next one, when we are adding something, we want also delete the item. So delete queue. There also two items are there. First part is the name of the queue from where we want to delete the item. Then the item means the item that we want to delete. So delete queue of queue comma item. Delete an item from the queue, letter Q. Then what is the letter Q? The letter Q means the name of the queue. From that queue we can delete an item. The next of queue removes the least recently added item that remains in the queue and return it as the value of the function. So next of queue means removes the least recently added item and remain that item in a particular, it will return the removed item by using the function. Then is empty, that we want to check before deleting an item. We want to check that something is there. So if something is there, then only we can delete that item. So is empty means create queue of queue. then is always true. Then is empty means we can true means it's a return the value true, means it's a boolean value, and is empty is always true. When we are creating first time, we know that when we are creating the queue, nothing will be there inside the queue. So is empty when we are creating, that is empty of create queue. Is empty, it's a function. Is empty is a function, and by inside that function we are using create queue of queue. Create queue of queue means we are creating the queue in the first time. So when we are creating a queue in the first time, always is empty is true, because after creating the queue can only add elements. Then delete queue of create queue. So delete queue of create queue means we are going to delete a queue, that queue that we are going to create. So it's not possible. So before creating a queue, deleting that queue is not possible. That why here it shows that it will be an error. So these are the operations that we can implement in a queue. First thing, create queue. Then that means we want to create a new queue. When we are creating a new queue, it will be empty. The next one is empty. Then after creating, we are inputting some items, or we are adding some items into the queue, and after that we are checking is the queue, and after that we are deleting, then adding, deleting, and in between we are checking is the queue is empty. So is empty, then the result for is empty will be a boolean type value. Boolean type value means maybe a true or false. Then add queue. Add queue means we can add items into the queue. Delete queue means we can delete items from the queue. The next queue means remove the least recently added item from the queue, and we can check is when creating is empty, we can check that the created queue is empty. Always it will be true. Then delete queue, it's not possible to delete a queue before it is created, so it will be an error. Then next part, implementation of queue. So we discussed about the queue, and now we are going to implement the queue. So in between, all of you have to share your enrollment number and your name in the chat box, so that I can copy it and hand it over to the center, okay, study center. So implementation of queue, a physical analogy for a queue is a line at a booking counter. We are saying one example. At a booking counter, customers go to the rear end. For example, we are entering into a booking counter or a railway booking counter or somewhere. So there may be some rails are there in between, and between the rails we can enter into the queue. We are entering at a booking counter, customers go to the rear end. So we are getting the service in the front end. We can simply imagine that we are going to a booking counter of railway booking counter or somewhere. Then we are entering in between, rails are there in between, so we are entering entering from the rear end. So customers go to the rear end, that is the end part of the line, and customers are attended to various services from the front end. So the person who is providing the service will be sitting in front of the queue. For example, we are collecting cinema tickets. Now we are collecting the cinema tickets through online. So in the previous days or before that, or now also we are going to, now we are not going to the theater. Okay. Customers are attending to, or best example is that beverages, right? There we can see the big queues, and they are getting the services in the front end. Those who are coming will be added to the back end. That is the best example. So customers are attending to various services from the front of the line. We are adding the back, and those who are coming first will be getting the service from the front. So unlike stack, customers are added at the rear end and deleted from the front end in a queue. So in stack, first in will be the last out item, or the last in will be the first out item in stack. But in unlike that, uh, in a unlike stack, customers are added at the rear end. In queue, the customers are added from the rear end. So customers are added at the rear end and deleted from the front end in a queue. So we call it as the first in, first out. Those who are coming first will be out first. So an example of the queue in computer science is print job scheduled for printers. So we can say the best example in computer science, this queue, as when we are sending, we can send multiple prints by using different computers. So we are installed a printer in a network, and in that network so many computers are there, for example, and we are giving the print jobs from different computers in different times, or in between times. So the first print that is coming will be scheduled as the first print that we are getting from the printer. So an example of the queue in computer science is print job scheduled for printers. So these jobs are maintained in a queue. So many print jobs are coming from different computers in a network. So what will happen? We have only one or two printers. So what will happen? The print coming, the coming print will be queued out. So the job fired for the printer first get printed first. So the job fired for the printer first. The first print job coming from the computer, any computer, will be get printed out first through the printer. Same is the scenario for job scheduling in the CPU of computers. So many jobs are coming to the CPU. The first job coming to the CPU will be scheduled first. So these are the two examples that we are using in computer science regarding this print. First one, print jobs are maintained in a queue in a printer, and same scenario for job scheduling in CPU. These two examples of implementation of queue in computer science. So like a stack, a queue also holds data elements of the same type. Means what? Like stack, a queue also usually holds data elements of the same type. For example, we are implementing this queue normally by using array or by using list or linked list. So in an array, we know that we can hold same type of elements in an array. For example, that is called same type. For example, here we use the character type char c of something, char c of 5 means what? We can store. The C is an array. The type of that array is a character type. Then we can hold a maximum of 5 elements in this array C. One more thing is that we can input or we can store one type of data. That is, we can store only this character type of data in this array C. And another array, that is int n of 10, means what? In this an array, we can store a maximum of 10 elements in this array, and we can store only integer type of data in this array. So a queue is also holds data elements of the same type. We usually graphically display a queue horizontally. Normally we are representing this queue in a horizontal manner, not in vertical. We are not representing the queue in this manner, but when we are using the stack, we represent the stack in a horizontal manner. But in Q, we are using this Q in a Q in horizontal manner and stack in vertical manner. Okay. Figure 5.1 that describe a queue of 5 elements. So, for example, this is the queue, and the elements that we can see is A, B, C, D, E, F. These are the 1, 2, 3, 4, 5, 6 elements are there. So, when we are representing a queue, in this queue, it contains two parts, that is the front and rear. So, the elements are entering, or the jobs are entering from the rear end and waiting the front end for getting services. So, the elements are entering to the rear end and it will wait in the front end for getting services. After getting the services, it will go out through this front end. So, this is the representation of queue. So, here 6 elements are there. The elements of 5 is not 5, 6 elements are there. So, the elements are entering into the queue from the rear end and getting services from the front end and go out through this front end. So, then the rule followed in a queue is that elements are added at the rear end. So, elements are added at the rear end and come off of the front of the queue, then entering through the rear end and go out through the front end. All of you are familiar with this. Then after the addition of an element to the above queue, the position of the rear pointer changes as shown below. Now the rear is pointing to the new element G added at the rear of the queue. So in this figure, for example, before adding the elements, for example, this is an empty queue. So this is the front part. All of you are familiar with that. This is the rear part. So when we are creating, nothing is there in this queue. So front and rear will be in the same position. Sorry, rear. Front and rear will be in the same position. This is an empty queue. We just created this queue, and we are adding one element in this queue. We are adding the first element, that is A, in this queue. Adding the A through the rear end. And what will happen? When the queue is empty, then the inserted element will be moved to the first position. Then again we are adding. Then what will happen? The rear will move to the front will be in the first position and rear will move to the next position. And we are inserting here. We are inserting another element, that is B. Then rear will point to the newly added element, front will be there. And again we insert another element, that is C. Then what will happen? When we are inserting new elements, the rear will move or rear will point to that element. And again we are inserting another element, that is D. Then what will happen? Front is there static and we are inserting another element, that is D. Then what will happen? The rear will point to that element and we are inserting element E. Then the rear will point to that element. And again we are inserting the element F. Now the rear will point to that element, that is F. And the last element that we are inserted is G. Then what will happen? The rear pointer will move to that element. So after addition of an element to the above queue, the position of the rear pointer changes as shown below. Now the rear is pointing to the newly added element, that is G, at the rear of the queue. I think it's clear. So when we are creating a queue, the friend and real will be in the same position. Then after inserting each element, what will happen? The rear pointer will be point to the newly added element. Okay. This is what is happening when we are adding elements. Then after the removal of the element, then the first element was A. So if you want to remove an element, is it possible to remove the last element? No, it's not possible to remove the last element, the newly added element. We can delete only the first element that we inserted. So after the removal of the first element that we inserted is A, and after the removal of the element A, what will happen? So before that, the friend will be pointed over there before deleting the element A. Then after deleting the element A, what will happen? After the removal of element A from the front, the queue changes to the following with the front pointer. Front pointer. What will happen? The front pointer? Front pointer will point to the element B. So when we are adding an element into a queue, what will happen? The rear will point to that element. Then when we delete an element from the queue, what will happen? The front will point to the next element. So when we are adding new elements, what will happen? Rear will point to that newly added element. Then front will be over there. That will be static over there. Then again we are adding another element. Then what will happen? The rear will point to that element. That element means the newly added element. And what happens when we are deleting an element from the queue? When we delete an element from the queue, the rear pointer will point to the next element. The first element will be removed. Then after that, the front pointer will point to the next element. Again, we are deleting the element B. Then what will happen? The front pointer will move to the next element, that is C. Again, we are removing the element C. Then what will happen? The front pointer will move to the next element, that is D. So this is happening when we are deleting an element, also when we are adding an element into a queue and from the queue. So then the algorithm for addition of an element to the queue. So we can do we can add an item or we can add element into the queue. So the algorithm for addition of an element to the queue. So the step 1, we are omitting the start and end. The first step, create a new element to be added. So the queue is there, the queue already that we created. Then the algorithm for addition, we want to, the queue is already there. So we want to insert or we want to collect the element that is to be added to the queue. So create a new element to be added. For example, A, the element that we want to add is A, that we collected. Then if the queue is empty, two possibilities are there. Maybe the queue is empty, that means the queue is just created or all the elements in the queue are deleted. So if the queue is empty, then what we want to do? We want to go to step 3. So for example, we just created the queue. Then the queue is empty. So we want to move to the step 3. What is in step 3? So make the front and rear pointer to this element. So we want to make the front. For example, this is the queue. The front and rear will point to that newly added element. So make the front and rear point this element. Then else means what? If the queue is not empty, then what we want to do? We want to, the queue is not empty, then we want to perform the step 4. What is in 4? What is in step 4? Add the element at the end of the queue. First we want to add the element at the end of the queue, the newly added. For example, A, B, C is there and we want to add the new element of D. We want to add this element. So add the element at the end of the queue. We want to add the element at the end. This is the end of the queue. So we want to add the element at the end of the queue. Then after that, end of the queue, and shift the rear pointer to the newly added element. So before adding the element D, the last added element was C. So what will happen? The rear will be pointing to that last or newly added element. Now we are adding another element. Now the newly added element is D. First we want to add the element at the end of the queue. Then what we want to do? We want to shift the rear pointer to that newly added element. So add the element at the end of the queue and shift the rear pointer to the newly added element. This is the algorithm for addition of an element. So, or to add an element into the queue. So first we want to, already one queue is there, that may be empty or something is there, some elements are there. So for adding an element into the queue, we should have an element. We should have the element. It may be A, or it may be B, or it may be C, anything. So first we want to create a new element to be added. Then after that, if the queue is empty, so we want to check if the queue is empty or something is there. So if the queue is empty, then go to step 3. First we want to check the, we can assign that the queue is empty. So first we want to do, we want to make the front and rear pointers to that element. Then if the queue is not empty, then add the element at the end of the queue and shift the rear pointer to the newly added element. So the rear pointer will be always in the last element of the queue. So the rear pointer will be always in the last element. It will point to the last element of the queue. Then deletion, algorithm for deletion of an element from the queue. Okay, first thing, check for queue empty condition. So if you want to delete an element from the queue, then something will be there. Then only we can delete element from the queue. So first we want to check that the queue is empty or not. If empty, then where we want to go to step 2. So if the queue is empty, then step 2. This is step 2. Message queue is empty. Then go to or exit. So if so check for queue empty first condition. If the queue is empty, then print the message queue is empty. It's not possible to delete an item from the empty queue. Then nothing, just exit. Then if the queue is not empty, means what? We can remove the first item. So delete the element from the front of the queue. First item means the element that is waiting in front of the queue. End of the queue. Then if it is the last element in the queue, then perform the step A, step 2. Step B. So for example, we are going to, first we want to check the queue is empty. If the queue is empty, then just print the message queue is empty, then exit. Then the queue is not empty. Then two conditions may be there. First part, only one element is there or more than one element is there. So if it is the last element in the queue, means only one element is there in the queue, then perform or go to step A, this one. Make front and rear pointer to null. After only one element is there, we want to delete that element. Then what will happen? When we delete an element, that queue contains only one element and we want to delete that element. Then what will happen? After deleting, the queue will be empty. So if the queue is empty, we want to the front and rear pointer, we want to point it to a null pointer or a null position. So if the front and rear pointer is pointing to null, means what? Pointing to null means that queue is empty. So only one element is there in the queue and we want to delete that element, then first delete that element and make the front and rear pointer to null. Second condition, more than one element is there in the queue. We want to delete one element, that is the element from the front. Then step B. So shift the front pointer ahead to point to the next element in the queue. So we know that A is there, B is there, C is there in the queue. And when we are deleting, what will happen? We want to delete the element A from the queue. Then after deleting this element, what we want to do? We want to shift the front pointer ahead to the point to the next element in the queue. What is the next element in the queue? B is the next element in the queue. So first we want to delete the first element from the queue and point the front to the next element. Front to the next element. So this is the algorithm for deletion. First we want to check the queue is empty. If so, nothing will do, just print a message and exit. Then if the queue is not empty, then two possibilities are there. First, only one element is there or more than one elements are there. So if only one element is there, then we want to delete that element and make the front and rear pointer to null. Then more than one element is there, delete the first element from front and move the front pointer or shift the front pointer to the next element. So this is the algorithm for deletion. Then next one, array implementation of queue. So now we are going to implement this queue by using array and linked list. So array implementation of queue. As the stack is a list of elements, the queue is also a list of elements. So why we are saying this is we already discussed about the stack. So this queue is also a list of elements. Some elements are there, A is there, B is there, C is there, so or 1, 2, 3, 4, 5. So this queue is also a list of elements. So the stack and the queue differ only in the, this is the difference between the stack and queue. Position where the elements can be added or deleted. So in stack we are using one fashion of addition and deletion, and in queue we are using another fashion of addition and deletion. So for example, we are using a stack. So we are the inserting and deletion will be in one end. And when we are inserting, the inserted element will be moved out like this. We can add and delete through one end in stack. So the last element that we are inserted will be the first element that we are deleting. So we can say that last in, first out. In a queue, normally we are representing it in a horizontal manner. In stack we are normally representing it in a vertical manner. So in a queue, front is there, rear is there. The elements that we are inserting through the rear end and deleting through the front end. So in queue, the first in element will be the first out element. We can say like this, or the element that we are inserting first in will be the first out element. So position where the elements can be added or deleted is the difference between the stack and queue. Like other linear data structure, queues can also be implemented using arrays. So this queue that we can, because we already discussed in the first part that this is an abstract data type. That means we are saying the abstract part or the core part only. We can implement it by using array, we can implement it by using linked list, we can write program by using C or C++ or Java that we can use. We are explaining the abstract part or the abstract part of the data type. So as the stack is a list of elements, the queue is also a list of elements. The stack and the queue differ only in the position where the elements can be added or deleted. In stack, we are inserting and deleting in one end, and in Q we are inserting the element through the rear end and deleting the element from the front end. This is the difference. So the program 5.1 is the implementation of the queue using arrays. Then one program, that is 5.1, describes or explains the implementation of this queue by using arrays that I will discuss. So this is the C program hash include stdio.h. Is it possible to include this stdio by using double quotes or less than or greater than? It is also possible to include this stdio in double quotes. So then hash define queue length 50. What is this? This is a constant. Queue length is a constant. In C we are defining a constant by using the directive hash define, and we are not using equal to. Queue length equal to 50 is wrong. Queue length 50. Then here we used all capital letters. So when we are assigning constants, normally we are using capital letters. Then struct queue. What is this? We are defining a structure. What's the use of this structure? What's the difference between this array and structure? In array we can hold only one type of elements, and in structure we can hold different types of elements. So here we used only one type of element. So int element queue length means what? Int element of 50. The value of queue length is 50. So we are assigning, or we are declaring an array named element, and the size of that array is 50 by 0. Then some integer type variables are also assigning, that is in front, rear, choice, x and y. So these are some integer type variables that we are declaring, not assigning but declaring. Then this is the end of the structure. Then struct Q, that is the name of the structure. In Q, this is the structure data type. Q structure data type, that is Q. Then main function. Then in choice comma x, print enter 1 for add and 2 to remove element from the queue. Then when we are running this program, then it will display the message enter 1 for add and 2 to remove element from the queue. So then enter your choice. Then after it will printing it, it will also display the same the message enter your choice. Then after that scanf %d ampersand choice. So it will wait for the input. When we give the input, some semicolons are there. When we give some input, that input will be copied to the variable choice. Then based on that choice, here we are using the switch statement, switch of choice. Then case 1, if the value of choice equal to 1, then enter element to be added. It will print the message enter element to be added. Then scanf %d ampersand x. The insert element will be saved in the variable x. Then add ampersand q comma x. Then what is this? This is the function. Here we call the function add. The name of the function is add. Then what will happen? The control will move to the function definition of add. So add of y. Here we use the address of operator. Then it will directly go to that memory address. Then x means this is the newly added element. That value will be given to the variable y. Then plus q dot rear. The value of q will be added by 1. Then if q dot rear less than q length, we are checking that the queue is already full. If so, not full. If so, then q dot element of q dot rear equal to y. So the newly assigned position will be added to new element. Else means the queue is full. That means q dot rear less than q length is not less than q length. That means the queue is full. Then we want to print the message queue overflow. it is not possible to add new elements into the queue. Then when the close brace is there, then the control will be moved to the called function. Below that called function, it is break. Then it will move back. Then case 2. Case 2 means to remove element from the queue. So case 2, delete function. So no arguments. Delete can be only through the front end, the first inserted element. So when we saw this function, the control will move to the delete function definition. Then if q dot front greater than q dot rear, then this is not the actual program. Printf q is empty means what? Nothing will be there for deletion. Else x equal to q dot element of q dot front means what? The first element will be copied to the variable x. Then q dot front plus plus, the front will be increased. Then return x means the deleted element will be returned. So this is the program. This is the simple C program for the implementation of insertion and deletion. Queue insertion and deletion. The next one, linked list implementation of a queue. So we are not explaining the program, but we are explaining the concept. The basic element of a linked list is a record. All of you are familiar with that. The basic element or basic concept of a linked list is a record structure of at least two elements, two fields. At least two fields means if it is a singly linked list, then we should have a data part and an address part. So at least two fields will be there in a linked list, in a simple linked list. That means a singly linked list. So the basic element of a linked list, that we are saying it as a record. Two elements are there in that record. The first element is the data and the second one is the pointer to the next element. The objective that holds the data and refers to the next element in the list is called a node. Normally we are saying it as a node. This is the representation of node representation of linked list. So first part is the data and PTR NEXT. PTR means pointer, NEXT means next. That is the pointer to the next data item. So this is the linked list implementation of queue. Normally we say it as a record. Linked list is record, and the simple linked list should have at least two elements. That is the data part and the pointer to the next data item. So linked list implementation of queue, the data component may contain data of any type. So in the data components may be contain the data of any type means the data part, it may be a character type data or integer type data or float or a double, any data type it may be. Then the pointer is a reference to the next element in the queue structure. All of you are familiar with that. This in a linked list concept, one data part is there and the pointer part is there. The data part holds the data and the pointer part holds the next data item's address. So this is the front and this is the rear. Means insertion is happened through this rear and deletion through front. So two programs are there. So figure 5.5 describe the linked list representation of a queue. This is the figure 5.5 linked list representation of queue. So front, this is the data part and this is the pointer part. This is the blue color is the pointer part. Then here also this is the data part, this is the pointer part. Then this is the rear end. Through this rear end insertion is happen and through this front end deletion will be happen. So two programs are there. Program 5.2 gives the program segment for addition of an element to the queue. So this 5.2 program is there in your textbook. Just go through and that explains the addition of elements into the queue, and for program 5.3 gives the program segments for the deletion of the element from the queue. So array implementation that we already discussed by using a C program, and here also Two programs are there. You just go through that program, and that is the program. First program, that is 5.2, gives the program segment for the addition of elements, and 5.3 deletion of elements from the queue. Then implementation of multiple queues. So multiple queues are there. Multiple queue means what? More than one queue. So multiple queue is a data structure where multiple queues are maintained. So multi-queue is a data structure where multiple queues are maintained. Multiple queues means more than one queue is there. So this type of data structures are used for process scheduling. Process scheduling means process scheduling that happens inside the CPU. So we may use one-dimensional array or multi-dimensional array to represent a multiple queue. So here also we are using arrays. One-dimensional array may be used for representing multi-queues, or multi-dimensional array may also be used for representing multi-queues. So how it is possible to represent one-dimensional array for representing multiple queues? So here we can see that 1, 2, 3, 4 up to n. This is the first queue. We are normally that we are dividing a big array into different parts. A big array into different parts. This is the first part, starting from 1 to n. 1, 2, 3, 4, 5, 6. This is the first queue. And next queue starts from n plus 1 to 2n. This is the Q2. And the third queue is starting from 2n plus 1 to up to that number. This is the Q3. This is the Q3. And next queue is starting from here to ending here. That is the Q4. That means single dimension array, if you are using single dimension array, then we are dividing that single dimension array into different parts, and we are implementing the multiple queue in single dimension array like this. Then we are next part is multi-dimension array implementation. How we can implement this multi-queue by using multi-dimension array. So multi-dimension array, we know that so many rows are there. Row 1 is there, row 2 is there, row 3 is there, up to row n is there. So the first row represents the first queue, and the second row represents the second queue, and third row represents the third queue, like that. So we can implement this one-dimensional array and multi-dimensional array. You can use it for multiple queues. Then array implementation of multi-queue. One program is there. Program 5.2 gives the program segment using array for the addition of an element to a queue in multi-queue. So the function definition is only described here. Then add mq of I comma x. What is this I? And mq means multi-queue. Adding an element in a multi-queue. So I and x. I means add x to the queue I. So x is the element and I is the name of the queue. The first part is the name of the queue, and second part is the element that we are going to add to the queue. So in the I x is there, then plus rear of I, then if rear of I equal to front of I plus 1, that is the queue-full condition. So rear of I equal to front of I plus 1, then it will display that the queue is full. Else rear of I equal to rear of I plus 1. We are incrementing the value of rear by 1. Then mq, this is the name of the queue, mq of rear of I equal to x. So this is the name of the array. Then inside that the rear of I, we are dividing the array into different parts. So rear of I equal to the newly inserted element. Then deletion segment for the program segment of the addition of an element to here also. This is the same. Multiple queue. This is deletion. I think the same statement is there, but this is the deletion, the program for deletion. So Del MQ means this is a function. This is a function for deleting the first element from the Q. Delete the element from Qi. So in the x comma I, then if front of I equal to rear of I means Q is empty. Nothing is there inside that Q. Otherwise, x equal to MQ of front plus plus. Sorry, front of I. So in that variable x, the first element in the MQ will be copied. Then front of I equal to front of I minus 1. The front will be decreased by 1. The return of x, that deleted element will be returned. So this is the program. This is the implementation, array implementation of multi-Q. That program, the function definition, only the function definition is there. So this is the function definition for addition. Add an element into a multi-Q, and this is the function definition for delete an element from a multi-Q. So implementation of circular Q. So another type of Q is called circular Q. So before that, describing this circular Q, we have to know something. That is, one of the major problem with the linear Q is the lack of proper utilization of space. So in a normal Q, so then the major problem that we are facing in a linear Q is that lack of proper utilization of space. Suppose that the Q can store 100 elements. For example, we can store 100 elements into a Q. The maximum capacity of that array is 100. So that means we can store a maximum of 100 elements into that Q. And the entire Q is full. And after that, we inserted all the elements into that Q. So the maximum capacity is over. It is not possible to add one more element to that Q. So the maximum capacity of the Q is reached now. So it means that the Q is hold 100 elements. Means the full capacity of the Q is exceed. In case some of the element at the front are deleted. So some of the element in the front are deleted. For example, this is the Q and the maximum capacity of the Q is reached. We inserted A, B, C, D, E, F. So the Q is full. Now it is not possible to insert more elements. And in this is the case. And now in this case, in case some of the elements at the front are deleted, what we are going to do? We are going to delete some elements from the front. We are deleting 2 elements from front. So now we are deleted 2 elements. So in the front, 2 spaces are there. Now rear is pointing the last element and front is pointing the third element. But we have 2 spaces are there in the front. So the elements are at the last position in the Q continue to be at the same position. So that means the rear is pointing to the last element. So the element at the last position in the Q continue to be at the same position, and there is no efficient way to find out that the Q is not full. So rear is at the end. Rear pointer is pointing at the end, but we deleted 2 elements from front. Actually 2 spaces are there in the front, but it is not possible to use. So in this way, space utilization in the case of linear Q is not efficient. So if you are trying to add more element to the Q, it is not possible, but 2 spaces are there. So this problem is arise due to the representation of the Q. So normal linear array representation of Q will be shows some difficulties like this. So this is the difficulty that we are facing in such a situation. So how we can solve or how we can overcome this situation? The alternative representation is to be depict the Q as circular. So in case we are representing the queue using arrays, then a queue with n elements starts from index 0 and end at n minus 1. That is the concept of array, starting from 0 and end with n minus 1. So clearly the first element in the queue will be at index 0 and the last element will be at n minus 1 when all the position between index 0 and n minus 1 both inclusive are filled. So we discussed that all the elements, the capacity of the queue is 100 and we filled all the elements, the 100 elements in that, we filled the 100 elements in the queue. Under such circumstances, friend will be point to 0 and rear will be point to n minus 1. However, when a new element is to be added and if the rear is point to n minus 1, then it needs to be checked if the position at index 0 is free. So that we already discussed that this is the array and here we have A and B are free, C, D and E is there and rear is pointing to the last element and front is pointing to the third element and two elements in the front are free. We can insert two elements in that position. So then it needs to be checked if the position at index is free, index 0 is free. So after that we want to check that the position, the element in the 0 index is free. If yes, then the element can be added to that position and the rear can be adjusted accordingly. So we can insert the element in this position. We can insert the element F in this position. Front is pointing here in the C element and rear should point to that newly inserted element. So in this way, the utilization of space is increased in the case of a circular queue. So it may be asked for your examination that the drawback of queue and how we can overcome this by implementing it by using a circular queue. This is the explanation, the first slide and the second slide. And this is in a circular queue and we are explaining what is a circular queue and what is the advantage of circular queue. In a circular queue, friend will point to one position less to the first element anti-clockwise. So in a circular queue there is no front and rear, right? In circle where we are assigning the front and we are assigning the rear. So in a circular queue, friend will point to one position less to the first element in anti-clockwise fashion. So if the first element is at position 4 in the array, then the front will be pointing to the position 3. So if the first element is at position 4, we are assigning the first element that is in position 4, then front will be in the position 3. When the circular queue is created, then the both front and rear point to index 1. So when we are creating a circular queue, front equal to rear equal to 1. So also we can conclude that the circular queue is empty in case both front and rear point to the same index. So when we are inserting and deleting, when we are inserting, what will happen? The rear will be increased. Then when we are deleting an element from a queue, then the front will be decreased. So like that, front and rear will be pointing to the same pointer. We can conclude that the circular queue is empty in case both front and rear point to the same index. So it is described in this figure 5.7, a circular queue, front equal to 0, rear equal to 4. So this is the circular queue starting from 0, 1, 2, 3, 4 like that, n minus 4, n minus 3, n minus 2, n minus 1. So when we are inserting, the rear will be increased. When we are deleting, the front will be decreased. So this is the fashion that we can implement this circular queue. So algorithm for addition of an element to circular queue, it's there. So step 1, if rear of the queue is pointing to the last position, then go to step 2. Rear is pointing to the last position. Then make the rear value as 0. If the rear is pointing to the last position, then make the rear value to 0. Then it is not, then go to step 3. Increase the rear value by 1. So if the front points where rear is pointing and the queue holds a not null value, then the queue overflow. That is the maximum element is already filled, and then quit. Otherwise, go to step B. Step B, add the new value for the queue position pointing by the rear. Where the rear is pointing, there we can insert the new element. So this is the algorithm for implementing the circular queue. Then deletion. Step 1, if the queue is empty, then say queue is empty and quit, else continue. Continue means we can delete an element from front. So if the front is pointing to the last position of the queue, then go to step 4. Make the front pointer to the first position in the queue and quit. So otherwise, increase the front position by 1. So normally we are applying this algorithm in queue, but in circular queue some difference are there. Then two programs are there, 5.1 array implementation of a circular queue, program 5.6 that you have to go through. Then that is the circular queue can be implemented using the array or linked list. Program 5.6 give the array implementation of a circular queue. The program is there in your textbook. Just go through the text. Then next one, 5.7 give the linked list representation of a circular queue. So two programs are there. Then the last one, that is DQ. DE means double-ended. So DQ means D means double, E means ended. So DQ, a double-ended queue is an abstract data type similar to queue. So where addition and deletion of elements are allowed at both ends. This is the opposite concept, but we are implementing this DQ, double-ended queue, that is the DQ. Double-ended queue means what? In one end, we can we are dividing a queue and we can insert and delete in both ends. So addition and deletion of elements are allowed at both ends. Like a linear queue and a circular queue, two types of queues that we already discussed, linear queue and circular queue. A double-ended queue can also be implemented using arrays or linked list. So the array implementation of a DQ 5.6 is there. In this, a program is there, 5.8, just a small program. 5.8 gives the array implementation of a DQ, and 5.9 gives the linked list implementation of a DQ. So these are the implementation of queues, double-ended queues. So I think this is the end of the slide. So we started from queue, then introduction, then objectives, then abstract data type queue, implementation of queues by using array and linked list, implementation of multiple queues, then circular queue, then double-ended queue. Then this is the introduction part, and the what is this abstract data type that we discussed. Then the operations, then creation of queue is empty, add, then delete, next queue, then implementation of queue, physically what is a queue and what is the front end, what is the rear end, then the first in first out fashion, then examples, two examples of computer science examples, that is CPU scheduling and the print scheduling. Then explanation of queues, how we can insert, then how we can delete elements in the queue. What is this front and rear? What happened when we insert the elements? What happened to rear when we insert the element, and what happened to front when we delete the elements that we discussed. Then two algorithms, addition and deletion algorithms that we have discussed. Then array implementation, how we can implement this array by using a program. And a linked list implementation, what's the concept of record in linked list that we have discussed. Then how we can implement this front addition and deletion, or add new nodes, add new elements in by using this linked list and delete. Then multiple queues are there. Multiple queue can be implemented by one dimension array and multi-dimension array that we discussed. Then the program, a small program, and the function definition that we have discussed. Then circular queue. Circular queue, the drawback of a linear queue, and that we discussed, and how we can overcome this by using this circular queue. Then double-ended queue, DQ, the representation of circular queue and the circular queue algorithm, addition and deletion. Then DQ, double-ended queue. And the double-ended queue program, two programs are there in your textbook. So I think this is the end of this unit. And if you have any doubt regarding this, this is the end of the unit. That the unit is 5, unit 5, Q, and the next one is 3. I think this is the end of the scheduled theory classes. And if we are getting enough time for practicals like this, then we will continue the theory. And from January onwards, if we can go to the study center, then we can do the practicals over there and try to complete the theory portions also. So this is the end. Next part is 3. So now we are winding up. So if you have any doubt, you can ask regarding this. And those who are not shared the your enrollment number and name, please share it in the chat.